Alright, if we're going to take the position versus time graph and we're going to translate it into a velocity versus time graph, the first thing that I need to do is calculate the slope on my position versus time graph for each segment. So for A, I have a rise of 20 meters, and I do that in 2 seconds, giving me 10 meters per second as my slope. For B, it's a flat line, meaning it has no slope, so 0 meters per second. And for C, I have a rise of 5 meters over the course of 4 seconds. So in order to solve for C, I'll take my 5 meters, I will divide it by 4 to give me 1.25 meters per second. All right. All my slopes are positive here, so I can start with my velocity versus time graph, and I can put 0 at the bottom. So this bottom corner is going to be 0, 0. My time axis should look the same because I am in fact graphing the same motion over the same period of time. Now I need to get as high as 10 meters per second. So 2, 4, 6. If I go up by 2s, I'll have enough room. All right. So for letter A, I travel at 10 meters a second, that's my velocity, and I do that for 2 seconds. So from 0 to 2, I have a speed of 10 meters per second. So that's letter A. From 2 seconds until 6 seconds, I'm not moving, meaning I have a velocity of 0. I'm going to connect those with my dotted line and label this B. And last but not least, I have 1.25 meters per second as my velocity from 6 seconds until 10 seconds. So halfway up is going to be 1. So just slightly above that is going to be my 1.25. Connect this with a flat line. You should use a ruler so yours looks better than mine. And label this section C.